Oh, hi there. This is mass to particles and using all three conversion factors. Divine. So, remember we have now three conversion factors. We have 1 mole is equal to Avogadro's number, which is particles or atoms or molecules. Particles can be lots of different things, as we know. We have 1 molecule equals the number of atoms, and finally we have 1 mole equals the molar mass. In this particular lesson, we're just going to put them all together and see how they can work as one. We're going to jump right into an example here. We want to know how many molecules are in 13.5 grams of sodium bicarbonate. So lots going on here. Let's see if we can figure it out. Again, same strategy as always. What am I looking for equals what do I have? I'm going to set it up like this. I'm going to show you a one-step solution, and then I'll show you an alternative solution. I prefer this method myself, but I'm going to show you two just in case you prefer to do this in 2 steps. So again, same as before. What I want to consider is what am I looking for? What do I have? So the question says how many molecules. So set it up as always. Molecules equals. That's a terrible color. Let me try again. Molecules equals. All right, next step, what do I have? They gave me 13.5 grams. All right, now it's time to look at my conversion factors and decide basically where do I start this off. One conversion factor is not going to cut it because if I look at my 3 options in the blue box on the top right, there is no one conversion factor that gets me between molecules and grams. I have molecules in a couple of different places. I have grams only in one place, which means I'm going to start with this conversion factor right here. It is the only one that involves grams, and the units, remember, are going to dictate my pathway here. So the first thing I want to do is I want to do my conversion factor where my grams are on the bottom so I can get rid of them, and my 1 mole is on top. So that means I have a little bit of side work to do as usual here because I need to figure out what the molar mass is of my compound. So let's do a little bit of side work here. My compound, I'm just going to do it at the bottom here. My compound was sodium bicarbonate or sodium hydrogen carbonate. Again, using our periodic table, we're going to put it together using our crossover rule. Then we're going to use our molar mass. So we've got 1 sodium, 22.99 grams, plus a hydrogen, 1.0079 grams, plus a carbon, 12.011 grams, plus 3 oxygens, 3 times 15.999 grams. So a grand total, if I bring it to 2 significant digits, we've got about 84.01 grams. If you can't remember how to do that, I show it to you a little bit slower in the previous video lesson, so go back and review. Let's bring that up here at the top, 84.01 grams. And again, that gets rid of the grams, but now it leaves us with moles. And again, that's not where I want to go with this, is it? I'm not done yet. If I don't have matching units at this point, again, what I'm referring to here is the fact that I've got moles, but I'm supposed to have molecules. This tells me I'm not done. Let's go back and have a look at the different options at the top in terms of conversion factors and see how I might use a second conversion factor here. So I want to get rid of moles. Conveniently, there's only one conversion factor I have not used that involves moles, so I'm going to now use this first conversion factor because I also know that particles can be converted to molecules since my sodium bicarbonate is a molecule. So I'm going to now add that conversion factor onto the end here. In this case, moles are on top in that second step. I now want to put moles on the bottom so I can get rid of them. I want Avogadro's number here at the top. Ooh, that's not what I want, right? Ooh, 10 to the 23 molecules. And that will allow me to get rid of my moles, and that now leaves me with molecules, which is precisely the unit. Oh, it's going to be one-eyed if I can't get my dot to work. Oh, there we go. And that's a close one, folks. And so there's what I've got. Now, math time. Everything's going to work out. It should work out, mind you, because I've got all my units worked out, which means the number should work out. So in our calculator, 13.5 divided by 84.01 multiplied by 6.02 exponent button 23. We're taking it down to 3 significant digits based on the 13.5 given in the problem. So 9.67 times 10 to the 22 molecules. Hopefully that's what you got as well. All right, let's show this same math in a 2-step process in case that's your preference. So I've just written down the conversion factors to have them again at the top, but we're going to use the same 2 conversion factors here. And the first thing I'm going to consider with this one is what do I have and what could I do with it? So it looks a little bit different than our previous strategy, which is why I prefer just to stick to the 1 step. But again, let's see what else we can do. So I was given 13.5 grams. And if I think about the given piece of the puzzle, now this particular type of method makes me think about, okay, which of the 3 conversion factors could I use? There's only one conversion factor that involves grams, so I could do a step where I convert to moles. And I often say, when in doubt, convert to moles, because that seems to be the name of the game when we're talking about grade 11 chemistry. So let's do that one. So I can use that first conversion factor to turn grams into moles. That means I'm going to look for moles using my mass. The conversion factor will put the mass, the grams on the bottom, and the 1 mole on top. My molar mass is the same as before, so 84.01 grams. We don't have to recalculate that. Grams will go, leaving me with 0.161 moles. Again, we're not done yet. I've solved for moles, but my question asks me for molecules. So again, if I want to consider, okay, second conversion factor is going to be needed here. How can I get from moles to molecules? There is a conversion factor to help me do that because particles can be changed to molecules, as we know. So I can do a second step where I'm going to look for molecules using my moles that I figured out in the first step. Setting up that conversion factor, I want Avogadro's number on top. And I want my 1 mole underneath so that I'm able to cancel out the units. It will leave me with the exact same number, 9.69 times 10 to the 22 molecules. So just an alternative way to do the exact same math, and depending on how you can make sense of the math, maybe this one makes more sense for you. You do you. Let's try one more example together. This one says, what is the mass of 3.20 times 10 to the 26 molecules of calcium perphosphate? And I've given you the formula there for calcium perphosphate, since that's a new one for us. That per on the end actually means just an extra oxygen in the phosphate part of the molecule there. So again, let's try this one on for size. Setting it up, we're going to do it as a 1-step solution to begin with, my preference. So again, we're going to look at the question and think about what am I looking for and what do I have. So what is the mass? So mass is what we are looking for, and then my number with the unit is what I have. Let's set that up on the next screen. So we've got our mass, and again, if you want to be really explicit, you can put grams in there to remind yourself what unit you need to end up with. That's fine. Our molecules is 3.20 times 10 to the 26. And again, my job here is to figure out, okay, how do I get this into mass? Now, my first job is to work out the molecules part. I need to get rid of molecules. I have 2 options here for our conversion factors. I can use the first one that gets, I can use the word particle. I can replace that with molecule, as I often do. So I could use that particular conversion factor. I could also use the conversion factor at the bottom potentially because it also has the word molecule in it. However, if I think about my end goal is mass, which means I need to land here. And that relationship involves moles. So the 2 relationships I want to use are actually these 2 once again. I don't want to bring in the last conversion factor because that's going to turn things into atoms for me, and I have no way of getting rid of that unit, and it's not the unit I want, so that's going to take me in the wrong direction. So let's ignore that 3rd conversion factor. I do not need it at this time. Using that first conversion factor first, then I'm going to use the second conversion unit second. Again, just driving the math based on units. So the first conversion factor, we're going to put Avogadro's number. I did not leave a space for a dot. My apologies. We're going to put that Avogadro's number down here at the bottom. That 1 mole on top. That's going to allow us to get rid of molecules. But again, my unit doesn't match still. I have moles left over. I'm supposed to go for mass. So that tells me use another conversion factor. So I'm going to tie in that second conversion factor. This time I'm going to put moles on the bottom because we want to get rid of those moles, and I'm going to put molar mass on the top here because I want mass to be in the end. A little bit of side work then to figure out my molar mass. I did give a formula for that calcium per phosphate. So working from this formula, we've got 3, maybe I'll do this one for you since it's a little more complicated. We've got 3 calciums, 40.078 grams each. We've got 2 times phosphorus. So anything that's outside the bracket multiplies by inside the bracket. So we've got 2 phosphorus, 30.974 grams each. And then again, I'm going to multiply outside to inside. So 2 times 5, 10 oxygens. And again, an oxygen's 15.999. Grand total then, 342.172 grams. Let's bring it back up to my conversion factor then. Ooh, I'm going to run out of space. I'll angle it. 342.172. Hopefully you did better than I did with the spacing there. Moles are going to go. And again, we're going to put it into our final answer with 3 significant digits based on that one given value. Mathematically, in your calculator, 3.20 exponent button 26 divided by 6.02 exponent 23 times 342.172. You should, at the end, you can pause and make sure you get this before revealing. I'm going to reveal now, so pause the button if you want to check yourself out, but you should get 1.82 times 10 to the 5 grams. I've put this into scientific notation just because it's a big number and I want to cut it off to 3 digits. So that's the way I've chosen to express it here. Once again, we could do a question like this into 2 steps. So based on the number given, 3.20 times 10 to the 26 molecules, and again, I want to convert it ultimately into grams. I could just go through the process of thinking, okay, I've got my 3 conversion factors. If I'm given molecules, what can I do with it? So again, when in doubt, solve for moles. So I could do this in 2 steps. Step 1 would look like this. Moles equals 3.20 times 10 to the 26 molecules. Using our first conversion factor, I can put moles on top, Avogadro's number on the bottom. That will get rid of my molecules unit, leaving me with 531.56 moles. That's just the first step. You'll notice I've got extra digits there. That's fine because again, I'm not at the end point. I don't need significant digits until the very last piece. So thinking again at the end point, I want to get to grams. So my second step would be to find mass using the moles. Oops. Oh, getting sloppy, getting sloppy. 6 moles. Again, using that molar mass from previous, so 342.172 grams. That's my molar mass that I found on the previous slide. We don't have to recalculate. Moles will cancel as per usual. And then our final answer looks the same as it did on the 1-step type of answer, taking it back to 3 significant digits, and again using that scientific notation because of the size. So either way, it doesn't matter to me how you want to do it. And of course, we want to make sure you have some practice at this. We didn't end up using that 3rd conversion factor in our examples today, but we easily could tie that on as an additional step. And in fact, we're going to add that additional step as a whiteboard challenge in class, so you may want to record that example into your note at the time that we do it. The more examples, the better. That's what I think. Cheers for now.